Hello everyone and welcome to this new video. So in today's video we're going to solve the third problem of the Euler project using Python 3, okay? So this is a quick video. We are going to solve this problem. So on this problem they asked us to calculate the prime factor number of a big number, okay? So in order to do that, they've made an explanation over here, and it says to to look for the prime factors of a number, and they are 5, 7, 13, and 29, okay? So those are the prime factors of this number, okay? So what does a prime factor means? So it means that the prime factor is only divisible by this number, and it's not divisible by another number except except the one and itself. For example, 7, it's not divisible by any number except the 7 and the 1, okay? So this is a prime number. If there is 14, the 14 won't be a prime number because the 14 is divisible by 2, so it won't count. Okay, so there's the 5, the 7, 13, and 29. So they have made an explanation, okay? So let's see over here what I've done, what I've wrote. So on this problem, it says to find the largest prime number of a number, okay? So there is several methods to do it, and I will show you two only, okay? So on that is easy, but would take a lot of time to run. But the other one is not easy, but took a short time to run, okay? So there is two solutions that I will provide you with today. Okay, so but let me explain what those solution be doing. So what is this algorithm? Okay, what is this algorithm going to do? So what is a prime factor? As I've explained to you earlier, let's give you another example. This is the 10. So this number can be divided by 10 on the prime factor. We won't take it itself as dividend, okay? So 10 is divisible by 10. So on the prime factor, we won't take 10 because it is itself. So you may say 1, okay? So we won't take also 1 as a prime factor, okay? Because the 1 is not counted, okay? Because on the definition, it is made that way, okay? So it's between 2 and the number minus 1, okay? So exactly, it's not only the number minus 1, but the smallest prime factor is 2, okay? In general. So it is the number minus 1 as definition of the prime factor. So when you divide it, you won't have any virgule, any comma before it, okay? So you won't need to find, for example, 13.7 or zero point 0.9. We won't need a point, okay? It would be an integer, not a float number, okay? So there is 2 and there is 5. Those are the prime factor of 10. And now let's see if those two numbers are also not divided by another number that's a prime factor of them. So if one of them is a prime factor, then then the number won't be a prime factor of 10. So 5 can't be divided by any number except itself and the 1. And it's a prime number and the 2 as well. Both are prime factors of 10. Okay? And now they asked us to find the biggest prime number. So on this case of the 10, it is the 5. Okay? So the 5 is the prime factor, the biggest prime factor, as they have asked us here to find the largest. So we will answer this question later on. And now I only explain to you what is prime factor and what is going. And now let's dig into the first solution. So here's the first algorithm that I have made. It's quite easy, but it will take a lot of time to run on the computer. So it would require a lot of resources in order to calculate this big number, okay? So we won't be doing this This is only to explain to you that there is several methods. Some of the methods may work well and others may not work well. Okay, so it's a very simple. There is a is prime function that returns if the number is divided by another number or not. Okay, so if it is divided by it, it will return false. If it's not divided, it will return true. Okay, so then there is another function which is the prime factor that runs two for loops. Okay, so this will be heavy for the computer to compile this because it has to go through all the number, and it will be difficult to track the big numbers that run two for loops that will go through the number divided by 2. So because 2 is the smallest prime factor, so I try to make it short. Okay, so this is number divided by 2, and then it will appear appended to the tab. So I've made a tab, uh, an array of numbers where I will append each prime number to it. And after that, I would call a max function, which will select the maximum of our array. Okay, so it would choose the biggest number of the array and show it to us. So I've made it that way. It would that would took after the biggest number, as I've explained to you now. The solution will take a lot of time. So because there is a loop inside of the loop, so the first loop would see if there is a prime number where the number would be divided by another one, and the second one would see if the number is divided by another number except itself and the one. Okay, so if it is in the case, it won't be a prime number, and then I have made an indicator. So an indicator would tell us if it is really a prime number or not. Okay, so there is two loops, and it will take a lot of time to run. And now let's take a look at the second solution. The second solution is a little bit complex, but it would work just fine. Okay, it have the same thing as our solution, but it is a little bit different, and it won't consume a lot of time. So it's using the same method. So here's the second solution. On it, we first got rid of the 3 and the 2 prime numbers, okay, and divided the number by them. So we won't go through all the numbers, all the number, okay. So it's using the same thing as the previous solution, except this is a little bit smarter. So we would get right, we would minimize our number. So for example, if it is divided by 2, we would take the maximum prime as a 2, and we will divide the number by 2. If it is a 3, divisible by 3, we will keep dividing by 3 and put the max prime number as 3, and so on. And after that, the 2 and the 3 we will go in a for loop. So I've made a range and the square root of n with a fit of 6. Okay, and then I've made loop over here, the while loop, and another while loop. This is a mathematical formula which would help us to find the prime number with least computational power. Okay, so then we go through only a part of the whole number, which would take a lot of time to compute. And here is the solution that they asked us for. So this is the question, and here is the solution with less computational power. Also, I have tried this using the language C with the compiler, and it would take several minutes. Okay, to compute, which is quite a lot of time compared to this one, the execution of this one, which took only a few seconds. Okay, not on not few seconds, less than 1 second. Okay, so let's see to show you how much time it would calculate the prime number of this, the maximum prime number of this number of 4 million. So with our first solution, it took more than 1 second. Okay, it took more than 1.29 seconds, which is quite a long time. And now let's see with the second solution. With second solution, it took less than 0.005 seconds, which is quite fast. Okay, it is really really fast, and it doesn't require a lot of computational power because of its function, because of the loops that are inside of it. Okay, they are not long loops, they are smart loops. Okay, so it won't go through all the numbers but except the parts where there is possibility of having a prime factor. Okay, so it is quite efficient. And then here is another example with our second solution, the number of the second solution and how much it would require to solve it. So here's this number, there's all this number, it's quite long number, and let's see how much time it would require. And it took less than a second. Okay, it took less than a second. The first solution would take maybe a few days without the GPU, okay, to be completed. It would take few days in order to calculate all this big number, which is quite a big challenge for us. Okay, and now let's continue. To sum up, you have to be careful on the choice of the algorithm that you are going to make. Some of them could take a lot of time but seems simple, but other would take less time and seems complicated. It's not a theory that the more complex an algorithm is, the more fast it would run. But you have to really know what's the problem you are dealing with. So, for example, here on our second solution, as you can see, there is many parts that would put our number smaller and smaller, which will take less computational power. But on our first solution, there is no conditions over here, and it is brutal with the number. It would take it as a whole. First, it would only divide it by two, okay, which is not a big deal, and then keep doing it over and over, which is not that much efficient. Okay, so yeah. You will find the code on the description as well as this PDF file, okay? If you want to go through what I've wrote over here. So yeah, this is it for today. Thank you for watching and bye bye.